In this lecture, we will work out with the problems. Okay. The main aim here is to solve a linear congruence equation which are simultaneous using the Chinese remainder theorem. When you want to solve the system of linear congruence relation using the Chinese remainder theorem, we require the method of finding out the GCD of two numbers. Number two, you should be in a position to solve a linear congruence equation, simple congruence equation. So, the first four problems will be on solving or finding the GCD and solving a congruence relation. Then we will solve two problems of using this Chinese remainder theorem. Okay, so that will be the pattern of this particular lecture. So now in the first problem, what we will do is we will find GCD of greatest common divisor of 1398 and 324 using Euclid algorithm. Okay, so in this case, what you do is you express this D in terms of AX plus BY, where X and Y are integers, and D would be GCD of A comma B. Okay, so this would be the pattern. Okay, this would be the process that we will be doing here. So in this case, what we do here is first express. Okay, let me first express this GCD in terms of. Let me express this GCD in terms of AX plus BY. So what are all the steps that we require here? Let me start with this. I will divide 1398 with 324. So I will have 324 into 4 plus 102. And now what I have to do is I have to divide 324 with 102. So that would be 102 into 3, which will give you 306 plus 18. Now what I will do is I will divide 102 with 18. So I will have 18 into 5, which would be 90, and then I will have plus 12. Okay. So now what I will do is I will divide 18 with 12. So I will have 12 into 1 plus 6. Now what I have to do is divide 12 with 6. I will have 6 into 2 plus 0. So in this case, this 6 would be the GCD of 1398 and 324, which would be 6. Okay. For our convenience, let me write this as equation 1, equation 2 here. This would be equation 3. This one would be equation 4. Okay. So now what I would do is I want to express this D in terms of AX plus BY. For that, what I do is I rewrite equation 4 like this. 6 is equal to 18 minus 12. Okay, from 4. Now I will express this 12 in terms of 102 and 18 using 3. So this would 6 would be 18 minus, I will rewrite this 12 as 102 minus 18 into 5. When I do it, minus into minus will become plus. 5 plus 1, 6. I will have 18 into 6 minus 102. So this I get from 3. Okay, from 3. So now I have 18 into 6 minus 102. So now what I will do is I will express 18 using 2 in terms of 324 and 102. So this would give you, this is equal to, this would be equal to 6 into, I will express this 18 as 324 minus 102 into 3 minus 102. This I get from 2. Okay, from 2. So now what happens here is that 6 would be, okay, I'll have this 6 into, okay, let me write like this. I'll have this 6 into 324 or 324 into 6. I retain this. 6 into 3 is 18 minus 1. So I'll have 102 into 19. Okay, so now what I have to do, I have to express this in terms of 324 and 1398. So I will use 1 and replace 102 with these two numbers, 1398 minus 324 into 4. Okay, so this gives you 324 into, this gives you 19 into 4 gives you 76 plus 6, 82 minus 19 into 1398. So in this case I can write this as 1398 into minus 19 plus 324 into 82. So in this case the expression D is AX plus BY can be written like this, namely here for this problem 6 is rewritten as 1398 into minus 19 plus 324 into 82. Okay, and the equation, if you have like this, AX plus BY is equal to D, is called as a Diophantine equation. And you can also find the integer solution, okay, integer solution of these Diophantine equations. So this is Euclidean algorithm. I have expressed the GCD in terms of integers x and y and known integers a and b. And the process is very simple. Keep on dividing until you get you make the remainder to be 0 at one stage. So repeating this Euclidean algorithm, we get the GCD of two numbers. Okay, so here we complete problem 1. I will proceed with the next problem. Problem number 2. Find GCD of 1900 and 435. As usual, using the Euclidean algorithm, I will divide 1900 with 435. I'll have 4 plus 160. Now what I have to do is, I have to divide 435 with 160. So I'll have 160 into 2 plus 115, 320 plus 115. So now what I have to do, I have to divide 160 with 115. So I'll have 1 plus 45. Good. The next step, 115 has to be divided with 45. I'll have 45 into 2, 90, 100 plus 25. The next one, I have to divide 45 with 25. I'll have 25 into 1 plus 20. And then the next step would be dividing 25 with 20. I will have 5. And then the last one here would be 5 into 4 plus 0. So I can conclude the GCD of 1900 and 435 is 5. Okay, is 5. So I'll have this. Okay, let me write this: equation 1, equation 2 here, equation 3, 4, 5, last one would be 6. Okay, let me express this D in terms of AX plus BY. Okay, so now let me write down here from 6. Okay, from 6, I will rewrite 5 as 25 minus 20. Okay, 25 minus 20. Okay. Now, what I will do here is I will express this 20 in terms of 45 and 25 using 5. So this would be 5 is equal to 25 minus, I will rewrite this 20 as 45 minus 25, okay, from 5. I'll just write down equation 5 from 5. So this reduces to 25 into 2 minus 45. Okay, so now what do I have? I have here 5 is equal to 25 into 2 minus 45. Good. Now I have used 5. Now I have to use 4. I have to rewrite 25 in terms of 115 and 45. So now what I get? 2 into 115 minus 45 into 2 minus 45. This I get from 4. Okay, so now this reduces to 2 into 115 minus 2 2s are 4. 4 minus 1 5, 45 into 5. Okay, so now what I have done? I have used 25, 4. Now I have to replace 45 using 3. So I will have 2 into 115 minus 5 into, what is 45? 160 minus 115. This I get from 3. Good. So I'll stick this, put this tick mark here. So I'll have 5. So I'll have 115 into 7 minus 5 into 160. Okay, minus 5 into 160. Now I have to use 2. What is 2? 115. I have this 115. So 115 is replaced as 435 minus 160 into 2. Okay, 160 into 2 minus 5 into 160. This I get from 2. Okay, so now when I simplify this, I will have 435 into 7. I will have minus 160. Okay, 7 into 2, 14 minus 5. I will have 19 into this. Now what I have to do is, I have to replace 160 using 1. So I will have 435 into 7 minus minus 19 into 160 is replaced as 1900 minus 435 into 4. Okay, so now when I do it, I will have 435 into, okay, this would give you 76, 676. So I will have 83 minus 19 into 1900. So I will have this part like this. Okay, 5 is equal to 435 into 83 plus 1900 into minus 90. Okay, this would give you the part ax plus by is equal to 5. Okay, let me see this, whether the working that we have done here is right. Okay, so now you have like this 4. Okay, I mean 14 into 9. Good. So this would give you the required solution. Okay, so now we have completed the solution of the second problem, namely finding the GCD of 1900 and 435. Okay, so now the third part, okay, the third part is solving. Okay, the third part is nothing but solving a congruence relation AX congruent to B mod n. Okay, so what is meant by this congruence? A congruent to B mod m is nothing but A minus B is divisible by m. Okay, So if you look at the right hand side you have a minus b is divisible by m. In other words, a minus b is equal to some constant k times m. So in this case, what we have to do is you have to find x such that a into x minus b is divisible by n. So for that, what we do is we first find the GCD of numbers a and n. Okay. So now if you find the GCD of a and n, and when this GCD divides b, then you can say that it has got d solutions. And if it does not divide b, then the linear congruents do not have a solution. So this is the process in which you have to find the solution to the linear congruence relation. Okay. So the next step would be this. Okay. Now what we do here is problem number 3. Solve 7x congruent to 1 mod 3. Okay. So now let me write down the general format here. Ax congruent to b mod n. Okay. I match and write the corresponding values. A is equal to 7, b is equal to 1, and n is equal to 3. Okay. So now d is equal to, this will be GCD of 7 comma 3. Okay, so now what I will do is I will find GCD using the Euclid algorithm. 3 into 2 plus 1. Okay, I can just stop with this saying that 1, because I have already reached 1. So if I want to, let me write down this. 3 would be 1 into 3 plus 0. So GCD is 1. GCD of 7 comma 3 is 1. Therefore, you can conclude that 7x congruent to 1 mod 3 has one solution. Okay. Now, I will express this 7x congruent to 1 mod 3 as 7x minus 3y is equal to 1. Okay, these two are same. So now what I have to do is I have to find x and y. Okay, in fact, find x itself is sufficient. Find x and y. So what I will do is, using this principle, I will express 1 is equal to 7 minus 3 into 2, which I can rewrite it as 7 into 1. Here I have 3 minus 3 into 2. Therefore, x is equal to 1 and y is equal to 2. Therefore, the required solution is x is equal to 1. So, when I multiply 7 with 1, I will have 7 minus 1, 6. 6 is divisible by 3. So, the solution to this congruence relation, 7x congruent to 1 mod 3 is 1. Okay. So, now this particular problem has got a unique solution. Suppose if I take another linear congruence equation and see that whether it has got multiple solutions, or how do we find the multiple solutions for congruence relation. Okay, let me write down here this problem. Find all solutions of, okay, I don't know whether you will have 1 or 2. Let me write, find all the solutions of 9x congruent to 12 mod 15. Okay, let me start with the solution as usual. In fact, I have to solve this equation. 9x minus 15y is equal to 12. You keep this in mind. Okay, now what I do is I find the GCD of a and n. So a is 9, b is 12, and n is 15. Okay, so now what I take D is equal to GCD of A comma N, which would be GCD of 9 comma 15. Okay, so now what I do is I express 15 in terms of 9. 9 into 1 plus 6. Now I have to divide 9 with 6. So I'll have 6 into 1 plus 3. Now I have to divide 6 with 3. 3 into 2 plus 0. So here I have GCD. Okay, GCD of 9 comma 15 is 3. Okay, so now what I do is I express this 3 as 9 minus 6 into 1. Okay, 6 into 1. Now I will replace this 6 with I'll replace this 6 with 15 minus 9. Okay, so I will have 3 is equal to 9 into 2. Okay, 9 into 2 minus 15. Okay, minus 15 into 1. Okay, and now you can just compare these two equations. When I compare these two equations, these two are one and the same, except I have 3, but whereas the required is 12 in the right hand side. Now what I do is I multiply this with 4. Okay, multiply with 4. Okay, multiply with 4. I'll have 12 is equal to 9 into 8 minus 15 into 4. Okay, let me write down this here so that we can have an easier understanding. 9 into 8 minus 15 into 4, and this would be 12. So x is equal to 8 and y is equal to 4. Okay, so now I have x is equal to 8 as one solution. Okay, now you see here D is equal to 3 and B is equal to 12, and D divides B, okay, which is 3 divided by 12 is 4. So this problem should have 4 solutions, and first solution is x naught is equal to 8. So now what do I get? This xi. Okay, xi would be x naught plus n by d into t. Okay, where t is nothing but 0. When I take 0, I have this 1, 2 and 3. Okay, and the I would be 1, 2, 3. Okay, so now what do I get when I take x1? Okay, this would be x naught plus n by d, which would be 8 plus 15 by 3, which would give you 15 by 3 is 5, so I'll have 13. And similarly, x2 would be x0 plus n by d into 2, which would give you 8 into 15 by 3 into 2, which would give you 18. And so I will have like this, x0 is equal to 8. Okay, 13 n by d. And now the next step would be, because I should have 4 values, now what will be x3? Okay, I'll have x3, which will be x0 plus n by d into 3. This will be 8 into 15 by 3 into 3, which will give you 23. So these are the solutions: 8, 13, 18 and 23. So these are the solutions to the given congruence, namely 9x is congruent to 12 mod 15. So in this case, you have to remember these two, namely finding the solution to the linear congruence and finding out the GCD of two numbers. So these two will be used these two will be used to find the solution of simultaneous linear congruence equation. Okay, so now let me write down this. Okay, what do I get? Okay, now let me write like this. Suppose if I take a system of congruence relation, let me write like this: A1, okay, x is congruent to A2 mod M2. Okay, so on. I have x is congruent to an mod mn. I have to solve this. Okay, write down like this. Let me solve this. Okay, let me solve this. I'll be using the remainder theorem. So now how to find out x? X would be A1 M1 M1 inverse plus A2 M2 M2 inverse plus so on plus AN MN MN inverse, okay, mod M. Okay, I'm just writing down the solution which is obtained from the Chinese remainder theorem. So now what would be M? M would be M1 M2 so on MN, and Mi would be M by Mi. I is equal to 1, 2, 3 so on up to N. So now what you have to do is you have to find out, you know, A1, A2, AN. You have to find capital M1, capital M2, capital M3 and find M1 inverse with respect to the corresponding mod function, and when you can do it, you can find the solution like this. Okay, so now it consists of three stages. First stage is finding out M1. The second stage is finding out M. The second stage is finding out MIs. Then finding out the corresponding MIs inverse, and then using this expression to find the solution to the given system of linear congruence equation. Okay, so now let me move to a particular problem so that we can easily understand the process. Okay, let me write it down in the next slide. It will be more better. Solve. Okay, take like this. Solve x congruent to 3 mod 11. The second one is x congruent to 5 mod 19. The third equation is x congruent to 10 mod 29. Okay, so now let me write down the solution here. A1 is 3, B1 is A2 is 5 and A3 is 10. M1 is 11, M2 is 19 and M3 is 29. Okay, so now first I will calculate M, which would be M1, M2, M3. Find the product of these three, 11, 19 and 29. So that turns out to be, okay, 6061. Now let me calculate M1, which would be M by M1. Will be 6061 divided by 11, which is 551. Okay, and then the value of M2 would be M divided by M2, which would be 6061 divided by 19, which turns out to be 319. And the third one is M3, which is M by M3, which is 6061 divided by 29, which turns out to be 209. So you have calculated M, you have calculated M1, M2 and M3. So now what you have to do is you have to calculate M1 inverse. Okay, M1 inverse. Let me do here. what will be the next step? The first step would be, let me write down like this, to find M1 inverse. Okay, what is this M1 inverse? That is 551 inverse mod 11. Okay, with respect to this, M1 was 551 mod 1. Okay, so now what you do is, I'll write like this, let alpha is equal to, okay, let me write like this, alpha is equal to or congruent to 551 inverse mod 11, or 551 alpha is congruent to 1 mod 11. Okay, as usual, this resembles the solution of the congruence relation. So now what I will do is, I will use the method that I used for the previous two problems to find the value of alpha. That would give you the value of M1 inverse. So first what I do is, I divide M1, namely 551 with 11. So I'll have 50 into 11 plus 1, 550 plus 1. So now what I have to do is, I have to express or divide 11 with 1. So 11 plus 1 is equal to 0. So in this case, when I do rewrite this, I will have like this, 551 minus 11 into 50 is equal to 1. Okay, so this resembles the form 551x minus 11y is equal to 1. So from this, I can conclude that M1 inverse is 1. M1 inverse turns out to be 1. So here you just remember this, M1 inverse is 1. Okay, so you can have like this, this would be 551 alpha minus 11y is equal to 1, and this is here. Okay, so now when I compare this with this equation, I am able to see that M1 inverse alpha is equal to 1. Okay, so now similarly I have to calculate M2 inverse. So how do we do this? To find M2 inverse. Okay, so now what is this? 319 x is congruent to 1 mod 90. Okay, you can see here M2 was 319. Okay, and the mod function corresponding to it was also 19. M2 was 19, so I calculated this. So now let me express this 319 or divide 319 with 19. So I'll have 19 into 16 plus 50. So I have to divide 19 with 15. So I'll have 15 into 1. Okay, plus 4. I have to divide 15 with 4. So I'll have 4 into 3 plus 3. And now when I divide 4, I'll have 3 into 1 plus 1. 3 into 1 plus 1. And when I divide 3, that would be 1 into 3 plus 0. Okay, so now I have this. Now let me rewrite as we did earlier. 1 is equal to 4 minus 3 from this equation. Okay, I will express this 3 using 15 minus 4 into 3. I will retrace the path as we did in the case of problem number 3. So this would be, so minus into minus would become plus 4 into 4 minus 15. Okay, so now what I will do is I will replace this 4. 4 into 19 minus 15 minus 15. So I will have 19 into 4. Okay, 19 into 4 minus 15 into 5. Okay, so now what I have to do is I have to replace 15 here. So I will have 19 into 4 minus 5 into 15 can be rewritten as 319 minus 19 into 16. Okay. So now when I do this, I'll have 319 into minus 5. Okay. So minus into minus would become plus. I will have plus, okay, let me write down like this. Plus 19 into, okay, so now what do I get? I get 16 into 5, 80, 80 plus 19, 99. Okay, I'll have 99. Okay, so now in this case, if you look at this, M1 inverse, sorry, M2, not M2, M1. So it is M2 inverse, okay, is nothing but minus 5 mod, okay, be minus 5 mod 19. Okay, so now what I have to do is I have to subtract 5 from 19. So M2 inverse would be 5. Okay, when I have this minus sign, I have to proceed from 19. Okay, this 19. So 19 minus 5 would give you 14. So M2 inverse turns out to be 14. Now what I have to do is I have to find the value of M3 inverse. Okay, so now what do I get? To find M3 inverse. Okay, so this will be little bit yeah, is congruent to 1 mod 29. Okay, so now we have to check this. Okay, when you check this, what do you get? M3, okay, you would have got M3 as 209 and the corresponding mod function contains 29. 209 x congruent to 1 mod 29. Okay, so now what I have to do is, as usual, I have to divide 209 with 29. So I'll have 29 into 7 plus 6. Okay, so now what I have to do? I have to divide 29 with 6. 6 into 4. Okay, 6 4s are 24. I will have plus 5. Okay, so now what happens here is that 6 into 4 plus 5. Okay, so now I have to now divide 6 with 5. Okay, so now what do I get when I divide 6 with 5? Okay, what do I get here? And this turns out to be like this. Okay, I have like this. 6 is equal to 5 into 1 plus 1. Okay, and now what I have to do? I have to write 5 as 1 into 5 plus 0. Okay, as usual, what I do is from this I have 1 is equal to 6 minus 5, and I will replace 5 with 29 minus 6 into 4. So this gives you 6 into 5 minus 29. Okay, now what I do is I replace 5 using the first one. 209 minus 29 into 7 minus 29. So this gives you 209 into 5 minus, okay, you'll have this minus 36 into 29. Okay, minus 36 into 20. Minus 29 into 36. Okay, so now your value of x is 5. Okay, value of x is 5. That is M3 inverse is 5. Okay, so now you have calculated M1, M2, M3, M1 inverse, M2 inverse and M3 inverse, and from that you have also we have calculated M1 inverse. So now using this you will find x. Okay, so now let me write down x. X is equal to a1 m1 m1 inverse plus, okay, a2 m2 m2 inverse plus a3 m3 m3 inverse mod capital M. Okay, so now let me write down the corresponding values. Okay, I'll have 3 into 551 into 1 plus next one was 5 into 319 into 14 plus 10 into 209. Okay, 209 into 5. Okay, and your M was 6061, so I'll have mod 6061. Now when you multiply this, you have 3 4 4 3 3. Okay, and this would be mod, okay, 6061, mod 6061. Okay, let me do right like this, mod 6061. And when I divide this 34,433 with 6061, the remainder turns out to be 4128 mod 6061. Therefore, your value of x, which satisfies all the constraint, all the linear congruence equation, is this, namely 4128. Okay, so now you have solved a linear congruence equation, system of linear congruence equation. So now let me solve another problem in this. Okay, solve is be simple with smaller numbers. 2 mod 3. Okay, x congruent to 3 mod 5. Okay, the third one would be x congruent to 2 mod 7. Okay, so now let me write down the solution like this. Okay, what is your a1? A1 would be, okay, a1 is equal to 2. Okay, what will happen to a2? A2 is 3. Okay, a2 as 3. And a3 is 2. M1 is 3. M2 is 5. And M3 is 7. Okay, now what I do is I calculate M, which would be M1, M2, M3, which would be 3 into 5 into 7, which is nothing but 105. You know what I do is I calculate M1, which is capital M by M1, which is 105 by 3, which would be 35. And M2 would be 105 by 5, which would be 21. Okay, and M3 would be 105 by 7, which would be 15. Okay, so now I will divide this into 3 streams so that we can do all the calculations here itself. Okay, so now M1 inverse. Okay, let me find M1 inverse. M1 inverse here. Okay, what is M1 inverse? Sorry, M1 inverse. Okay, so now I will have 35x congruent to 1 mod 3. Okay, and similarly M2 inverse 21x congruent to 1 mod 5. Is that good? And what is M3 inverse? Okay, M3 inverse would be 15x congruent to 1 mod 7. Okay, so now let me do here. 35 is equal to, okay, so I'll have 3 into 11 plus 2, and 3 is equal to 2 into 1 plus 1. Okay, so now this I can write it as 1 is equal to 3 minus 2, which would be 3 minus 2 is rewritten as 35 minus 3 into 11. Okay, so now 3 into 11. Okay, now when I do this, I will have, what do I have? I have 35. Okay, write like this. 35. I'll have like this. 3 into 12 minus 35 into 1. Okay, so your M1 inverse would be, okay, M1 inverse would be minus 1 mod 3, which would be 2. Okay, good, because coefficient of 35 is minus 1, so I have to reduce 1 from 3, which would be 2. Now moving here, okay, now moving to the second part, let me write down this. Okay, what do I get? 21 is equal to 5 into 4 plus 1. Okay, I get it is very simple. So 1 is equal to 21 into 1 minus 5 into 4. So I get M2 inverse as 1. This I get directly. Now what about M3? Okay, now what about M3 here? 15 is equal to 7 into 2 plus 1. Again I get the same thing. 1 is equal to 15 minus 7 into 2. So M3 inverse is also 1. M3 inverse is also 1. So I have calculated M1 inverse, M2 inverse and M3 inverse, and using this let me calculate X. Now what will be X? X is equal to A1 M1 M1 inverse plus A2 M2, okay, M2 inverse plus A3 M3 M3 inverse mod M. Okay, so now let me pick up all these values. 2 into 3 into M1 inverse was 2. Okay, M1 inverse was 2 here. Good. Plus A2. A2 was 3. M2 was M1 was 35, not 3, 35. And here M2 was 21 into M2 inverse was 1. And A3 is 2. Sorry, A3 is 2. M3 was 15 and M3 inverse of 1. Okay. So what I have to do is I have to have mod, sorry, not small m, mod capital M. Mod capital M was 105. Okay. So now what do I get? 70 into 2, 140 plus 63 plus 30. Okay, plus 30 mod 105. Mod 105. Okay, so now when you do this, okay, now what do you get when you add this? You get, this turns out to be, okay, this turns out to be 200, 203, 233, 233 mod 105. Okay, so now when I write down the remainder alone, okay, so in this case 105 into 2, let me write down like this, 105 into 2 this would give you 10 to 10. Okay, so when I remove this 2 10 here, I will have balance of 23. So the value of x is 23, or when I take x is equal to 23, the three congruence equation are satisfied. Let us make a small check. X congruent to 2 mod 3. This was the first equation. X congruent to 3 mod 5. This was the second equation. And x congruent to 2 mod 7. This was the third equation. So when I substitute 23 here, 23 minus 2 is 21. That is divisible by 3. Good. And here when I take the second one, what is that? When I substitute x is equal to 23, here I will have 23 minus 3. Okay, 23 minus 3. You will have 23 minus 3, which would be 20, which is divisible by 5. And 23 minus 2, which is 21, which is also divisible by 7. So in this case, you have a method of solving a system of linear congruence using the Chinese remainder theorem. Okay, so now I will take another problem. In the problem just we have solved, we have the coefficient of x to be 1. Okay, so now let me take a little bit complicated one or different one, namely taking the coefficient of x to be greater than 1. Okay, greater than 1, and then how to solve or how to use it, use the Chinese remainder theorem will be given as the last problem in this particular lecture. Okay. So now let me move to the next slide. Yes, I'll have like this: solve 2x congruent to 1 mod 3. The next one would be 3x congruent to 1 mod 4. 1 mod 4. And the next one would be x congruent to 2 mod 5. X congruent to 2 mod 5. Okay, so I don't have a problem with this equation, but whereas here I have a problem with this. I have 3x here, here I have 2x. So now what we do here is first I will convert these two in terms of a congruence equation where I have coefficient of x to be 1. I can write like this. This would be x congruent to 2 inverse mod 3. Okay, and I can write this as x congruent to 3 inverse mod 4. Okay, so now what I have to do is I have to calculate this. So now what do I do here is this, I can rewrite it as 2x minus 3y is equal to 1. Okay, as we did earlier, 2x minus 3y is equal to 1. Very simple. So now what I have to do is I have to express 3 in terms of 2. So now what I do is I divide 3 with 2, 2 into 1 plus 1. So in this case I have 1 is equal to 3 minus 2, or I will have like this: 3 into 1 plus 2 into minus 1. Therefore, okay, your x would be minus 1 mod 3, which would be 2. Okay, so this equation now becomes x congruent to 2 mod 3. Okay, very simple, because x is 2. So I'll have x is 2 inverse. So what I do is 1 by 2 will be rewritten as 2 here, because I have calculated this. So I'll have x congruent to 2 mod 3. So same is the process here. Now what I have is this, I can rewrite it as 3x minus 4y is equal to 1. So I will express 4 in terms of 3. 3 into 1 plus 1, or 1 is equal to 4 minus 3 into 1. As usual, here x is minus 1 mod 4, which would be 3. So in this case, this system of equation, okay, this equation becomes, okay, what will happen to this equation? This equation becomes x is congruent to 3 mod 4. Okay, so now instead of 3x congruent to 1 mod 4, I will take x congruent to 3 mod 4, and instead of 2x congruent to 1 mod 3, I will take x congruent to 2 mod 3, which I have simplified here. So now I will use the previous case, solving x congruent to 2 mod 3 and x congruent to 3 mod 4 and x congruent to 2 mod 5 gives the solution to the given system of congruence equation. So now what I do is I calculate m, which would be 3 into 4 into 5, which is 60. m1 would be 60 by 3, 20. m2 would be 60 by 15, which is 4, and m3 would be, okay, which is 4, and m3 would be, okay, sorry, I'm writing it in the other way, okay, m3 by m, okay, let me do here this. I'll have this 15, 60 by 4, 15 as usual. m3 would be 60 by 5, it will be 12. Okay. Now what I have to do is, you have to calculate m1 inverse. What is m1 inverse? Sorry. Plus 1. Okay. So now what do I get? Here, this I can write it as 1 is equal to 3 minus 2. And this will be 3 minus 2. I will rewrite it as 20 minus 3 into 6. So I will have 20 into minus 1 plus 3 into 7. So m1 inverse is 2. Okay, now I will calculate m2 inverse. What is m2 inverse? 15x congruent to 1 mod 4. So I will have 15 is equal to 4 into 3 plus 3. 4 is equal to 3 into 1 plus 1. Okay, I will rewrite this as 1 is equal to 4 minus 3. And this will be 4 minus 15 minus 4 into 3. which would be 15 into minus 1 plus 4 into 4, and this gives you m2 inverse is equal to 3. Okay, m2 inverse is 3. Now what we have to do is we have to calculate m3 inverse. So now what will be m3 inverse? M3 inverse would be 12x congruent to 1 mod 5. So you will have 12 is equal to 5 into 2 plus 2. 5 is equal to 2 into 2 plus 1. I will write this 1 as 5 minus 2 into 2, and this will be 5 minus 2 into, I will rewrite this 2 using the first as 12 minus 5 into 2. Okay, so now this would be like this, 5 minus into minus plus, so you will have 5 into 5. Okay, you will have 5 into 2 into 2, 4, 4 plus 1, 5, minus 12 into 2. So your m3 inverse would be minus 2. So when I subtract 5 minus 2, I get 3. So m1 inverse is 2, m2 inverse is 3, and m3 inverse is also 3. So let me write down this. X is equal to a1, m1, m1 inverse. Okay, a1, m1, m1 inverse, m1 inverse, because of the wetness in the board, you get like this. So you get the solution x is equal to, okay, this x is equal to a1, m1, m1 inverse plus a2, m2, m2 inverse plus a3, m3, m3 inverse mod m. Okay, mod m, mod m. Okay, so now let me write down these values. 2 into 20 into 2 plus 3 into 15 into 3 plus 2 into 12 into 3. Okay, mod 105. Okay, you can just make a check here. m2 inverse, m3 inverse, and m1 inverse are 3, 3 and 2. Let me check here. 2, 3, 3. Okay, a1 was 2, 3, 2. 2, 3, 2. Yeah, 2, 3, 3. 20, 15, 12. Okay, m1 20, 15, 12. And m was not 105. It is m is 60. Okay, not 105. So let me rewrite this. This would be 60. Okay, I have 60 here. Okay, so now when I simplify this, I get 40, 80 plus 46, 6 into, sorry, not 6, 15 into 3, 45, or we will write like this, 15 into 9. What will happen to 15 into 9? 135 plus 24 into 3, 672. Okay, 6 into 7. Okay, 6 into 12, mod 60. Okay, so now this would give you 152 plus 135. mod 60. So this would give you 7 H287 mod 60. So now I have to take the highest multiple of 60. Okay, so now when I remove this 60 into 4, 240. So I'll have the answer as 47. Okay, so value of x turns out to be 47. Now you check the given system of congruence. 2x is congruent to 1 mod 3. Okay, so now I'll have 2 into 47. Okay, 2 into 47 is 14, 4 carry 1, 94. Okay, I'll have 94 and 94 minus 1. Okay, 94 minus 1 is divisible by 3. Okay, so you have 94 and 94 minus 1 is divisible by 3. Okay, now what was the second equation that we had? Second equation that we had was 3x congruent to 1 mod 4. Okay, so now 3 into 47. Okay, so 21 carry 2, 12, 141. So 141 minus 1, 140, and this is also divisible by 3. Okay, 140 divided by 3. Okay, this would give you okay, 3. What will happen to this? 3, sorry, not 3, 4, because here 1, 4, sorry, 4. So I'll have 70 by 2, and this is nothing but 35. Okay, so now the second equation is also satisfied when I take x is equal to 47. Of course, you will have the answer. This is just for our verification purpose that we are doing here. Now the third equation was x is congruent to, that one is simple, x is congruent to 2 mod 5. So 47 minus 2 is 45 and 45 by 5 is 9. So you have these three equations. So in this case, if the coefficient is greater than 1, you have to reduce it to an equation where the coefficient of x is 1 and then use the usual process and try to solve it. So with this, we come to the end of this particular lecture, namely the problem solving lecture, how to solve a system of equations using the Chinese remainder theorem was discussed here, with the help of finding out the GCD of two numbers using the Euclidean algorithm, and then we solved an individual equation, congruence equation AX congruent to B mod M, and using these two concepts we were able to solve a system of linear equations using the Chinese remainder theorem. And if you have any queries in this, you can mail me to this email ID. I will answer your queries. max.sastra.ed. Thank you.